Okay, cool. Looks like we're recording. So Tracer can be found at apps.provingground.io. This is our main site. We have a number of different products ranging from Rhino Revit integration to Rhino and Power BI integrations. And today's section will be on Tracer, which is our BIM data harvesting approach with Power BI data visualization. So if you go to the Tracer site, you'll notice that we have a number of basically an overview here of what Tracer is. We're presently supporting versions of Tracer for Revit as well as IFC data. IFC is an open format that can be exported out of places like ArchiCAD, Revit, Tekla, and other modeling tools. So it kind of opens up an opportunity to integrate data from other building information modeling platforms, as well as a version that's dedicated to Revit specifically. We will be focusing primarily on Revit in today's session, but the data structures and the techniques that are used to compose Power BI reports are very similar across the Revit and IFC data structures that we're using here. So if you're interested in trying it out, we have a 15-day trial of both of these products available, and you can access that through our website here, and there are some perpetual license purchase opportunities as well. I also wanted to highlight that if you have follow-up questions or thoughts about or want to get involved with the Tracer workflow in a little bit more of a self-directed format, we do have a rather extensive set of documentation available. And this is something that we're always growing and adding to and evolving. You'll find that if you visit the site this month and you come back next month, for example, there will likely be more content to take apart and understand. I think one of the most popular areas of the site involve the video tutorials. So we have a set of tutorials here that get you onboarded to some of the new features in our recent release, Tracer version 3. We have tutorials that are curated for a general introduction to Tracer for Revit and IFC. We also have Power BI concepts and tips generally that might be helpful in your overall workflow. We do have templates for accessing data from Power BI. These are really powerful to get you going fast and get you connected to your data and visualizing things really quickly. I just realized I wasn't sharing my screen.
Oh no, we can see your screen.
Oh, you can?
Yeah.
Oh, okay. It says that I didn't have a share going. That's weird. Okay, cool. I figured you would have chimed in if you're like, Nate, you're not sharing anything.
Yeah, I got your back. Don't worry.
Good. Awesome. So yeah, these templates are really powerful ways to get started with making data connections and having some predefined layouts that you can obviously modify and adjust as you want. We also have some online examples that can be really useful to just get a sense of the kinds of reports that you can build. And everything that we're able to do with Tracer, you can publish the results to the cloud and let people navigate the resultant reports, share them with others. These are a couple of publicly published reports that just provide some example use cases and access three-dimensional information in the browser, access different data points, and really kind of show that you can really use Tracer and this technology to tell your story with building information model data. So with that, I'm going to pass the mic over to Nicole Mader, who is our Director of Product here at Proving Ground, and she is going to get us started on understanding the different workflows with Tracer in a live demo format. And at a certain point here, I'm going to also interject with a bit of a side quest on getting into some of the data technical components as well. So I'll pass it over to Nicole.
Great. Can you see my screen?
Yep, I'm seeing it now.
Perfect. So today we're going to continue on our exploration of arena data sets. If you tuned into the recent conveyor workshop, that you might recognize some of the elements that are on the screen. Both Nate and I have a background in arena and sports, recreation, entertainment design, and some of these exercises in creating data sets are a chance for us to rethink ways that we can do things maybe a little bit better than how we used to do them in the past. So this example and what we'll focus on today is looking at an arena seating manifest data set and how to make that an interactive experience, and also how to add on revenue projection information to the arena. One of the things that's really fascinating about a seating manifest is the relationship of the built space to the facility revenue. And it seemed like something that would be fun to show how we could use a very robust data set to create some of these visuals. There will be a lot of parallels to things that are not as specific as this, and we'll make sure to highlight those more generic operations, but this should give you a pretty deep dive into how to use these more robust data sets. So what you're looking at on the screen is an end state model of what we'll be exploring today. You can see that we have a 2D visual here that is a plan view of the different arena sections, and a 3D tracer view on the right-hand side of the screen. These are all interactive elements. So if I select a line in one of our charts over here, you can see how it selected that area in the 2D view, and then the 3D view is just regenerating. You can see the loading sign here, but it will go in and highlight those elements here in a second. There's 10,000 seats, so it's chugging, it's thinking about it. In addition to what you can see just in the visual, if I scroll in, you can see that we've added tooltips that are adding additional information when you hover over these elements. And we've also designated parts of this arena as context versus the data that has that additional layer of information added to it. I can switch over to another tab in this report, and we'll go through how to create this as well, but this is where we're starting to project some of that revenue information. And at the very end of the session, we'll show you an interactive, even more interactive, responsive dashboard that actually allows us to use sliders to create visuals where, as the revenue projections are changing, the visuals are updating all on one slide rather than having these 3 different discrete slides. So I'm pretty excited about this, and we'll get into it by first starting in Revit. We've built out just a quarter of the data to help the process go a little bit faster today. So you can see the quarter of the arena model here. And we've set up each of these seating sections as rooms. So a lot of the operations that we'll be showing you today have to do with using room data from Revit. And each of these seats are actually brought over, you can see in the properties tab from Rhino using conveyor in the workflow that we established in a previous workshop. And we'll show you how that all pipes into Tracer. So we're looking right now at a room plan view where each of the elements that we want to bring in to Tracer are visible. And it's a little bit hard for me to see because there's a zoom bar on top, so I'm going to minimize this a bit. What we'll need to do once this data is created and ready to go in Revit is navigate in the ribbon bar to the Proving Ground tab and select Tracer Exporter. I need to update my tracer. I'll do that later. So this is what the Tracer Exporter looks like. And there are a lot of different options in the exporter for what you can choose to pull from the data. We have a good idea of what the end state needs to be for this. So we'll be more selective about the data that we're choosing to export to try and keep things able to load quickly and efficiently. In the drop-down menu, you can see that we have different presets set up. Everything will export literally all of your data, both non-3D, non-in-space information, and all of the 3D information. Rooms, areas, and spaces will focus on just those types of data, and the same with shell and structure. I've created a new export preset for the seating bowl, but I'll show you how I did that versus just using that quick button there. So what we need to do for this is make sure that we have our 2D and 3D export identified. When we drop down this menu, you can see that it hides the Revit categories, but we can get that back in a moment. We will select our level of detail, and fine is appropriate for this case. We'll also set our smoothness, and because we have these curved elements here that we would like to look still curved and not faceted in the final view, I'll up the smoothness. 0.6 is probably okay. If we push this all the way to the top, it might make the file a little bared down with data and mesh facets. So we don't necessarily want to push it all the way up unless it's absolutely necessary. I don't think we'll need to compress this. And then this is an important point, to leave bounding box for large meshes unchecked. If we were to check this, then any meshes, like perhaps this portion of the seeding bowl that are deemed too large, will not be imported as 3D data into the data set. So we'll leave that unchecked. We can collapse that menu. And then in Revit categories, since everything we need is already visible in this view, we can filter to active view. And it's just going to shorten the list of information that's available here to things that are visible in the view. Once we've done that, we can uncheck the types of data that we don't need. So we can focus in on just the data that we're going to be using. And then for additional content, I don't think we'll need line styles or warnings, but it's an option to have those. Now that we have all of these created, if we wanted to save this as a preset, we could hit save here, and it would update the selected preset to be this new settings. We could also hit new and rename it. I thought I was selected on the stadium bowl export, so I'll have to go back and change my everything settings at another time. So we can go ahead and hit export, and I'll place these in our tutorial folder. And this is going to export hopefully relatively quickly. Here we go. With some exports, it will take much, much longer than this, especially if you have the bounding boxes for large meshes unchecked and very high smoothness and no compression, but that was relatively quick. So I'm going to open a template file. Nate showed you earlier where you can download those templates on our website. I'll show you again really quickly. It's under documentation, tracer, Power BI templates, and then tracer templates. These are really going to help kickstart the process because you don't have to worry about things like mesh concatenation or file setup. And when you open the template, you'll be prompted to add a file path to the database. So I will pull that up. This is the database that we just created. We can right click on it, copy as path, and then paste it into this file path box. Once I click load, it'll take a minute, and I'm going to hand the screen back to Nate so that he can describe the way that databases need to be put together on the back end to allow these visuals to work. One more quick note is you can either hit Windows for authentication or default or custom before hitting connect.
Great, thanks. I'm going to share my screen now, and we're going to do a little bit of a side quest into data connections and relationships. And these are general purpose, I guess, skills that you'll want to, I guess, develop as you start using Power BI, and can be very powerful as a way to connect between different tables of data and different data sets. So just to confirm, is my screen coming through, Nicole?
Yep.
Awesome. Okay. So the file that Nicole just exported is a SQLite, which SQL stands for Standard Query Language. And it has a really powerful way of connecting together various tables and organizing things into a proper relational database. So what I'm showing on screen right now is a little bit might be intimidating for some to see, but these are like the underlying guts of the database file. And you can see that this database is comprised of a number of tables that organize the data. And there are really maybe 8 tables that are going to be useful in everyday use. And that's going to be your document table. We have document level parameters, document tags, element tables, which store records of all itemized elements, and then parameter tables, which are then keyed in to different elements themselves. So if you wanted to find, for example, an element and then all of its text-based parameters, you would have a relationship that joins between element and element text. I'll show you this in Power BI. We also have a number of other components to these databases regarding what are called views. And views are stored queries in the database that would allow you to access, say, all floor elements and the floor parameters, for example, or all the room elements and all the room parameters, for example. So they're really meant to be helpful shortcuts that allow you to transverse this core data that's being stored in these tables up here. What we're going to be doing in this workshop is using the core data tables and the relationships to access different properties and build up visual views here. And so right now, this is a blank Power BI report. Nicole will go through a rather extensive process of building one up here in a bit. But you can see that we've made a number of data connections here. And if you wanted to see and review the raw tabular data, you can toggle off on the left-hand side between the report view and the data view. And scrubbing through these, we can see that we have a variety of different data records available. So this is the element table that has IDs for the different elements, the name of the element, unique identifiers from Revit, location, GeoJSON data, as well as mesh information. But one of the real bits of power with Power BI, pun intended, I guess, is to have a way to connect multiple sources of data, multiple tables of data, whether they're coming from the same database or several different databases. So relationally, this is how the tracer schema, the database schema, looks in terms of its various connections and relationships. So for example, we have a document record table that stores information about the Revit document that's been exported. So since we're dealing with tracer standard version here, you're going to have one model export. It's going to produce a document record here. You're also then going to have the document related to the element table. So one document is going to have a one-to-many relationship with all of the elements here. And what that means is if I go into this relational property, this is a join between those tables, you can see that we have a document ID, and this document ID is relating over to the elements table. And we have one document and then many elements in that document. Similarly, we have multiple elements, but then these elements have multiple parameters. So one element out of this record is going to have multiple parameters that might be related to, say, numeric parameters. If I drill down into this relationship here, you'll see that we have element records within a one-to-many relationship to all the parameters related to those elements. So this allows for some really powerful ability to atomize the different element records, have them stored in a scalable manner. And there's a question that just came through on the Q&A: is it possible to export from Revit more than one model together? You can export multiple databases and then use Power BI to join those databases together using the conventions about the schema. And in fact, we have a number of tutorials in our documentation that show you how to do this, and a template or two that explains how that's possible using the tracer standard version. We do have a centralized database solution that we won't be getting into in this call, but is really designed to store multiple models, multiple model records together in a single database environment. So I'm going to go ahead and cancel out of this. And what I want to do is show then the natural extension of this this concept to drill down and get to data that I might want to have. And as you get into Power BI, you're really going to want to understand data transformations. There is a command up on the upper ribbon called transform data. And this is where like the nuts and bolts of Power BI's data is captured. You make connections to different data sources. You might have multiple tables of information. In the transform data environment in Power BI, this is where you can access specific parameters. You can pare down records of different tables. You can transform the tables and do different things to them. So for example, what I might want to do here, because I know Nicole will be going through rooms and objects contained within rooms, is I might want a table that's broken out from my kind of main element record list that just contains the room data or the room element record. So what I can do is I can right click on this element connection that's been made to the database, and I can choose to either duplicate that connection or I can reference the existing connection. For efficiency's sake, referencing tends to be more efficient because you're making one connection and then that's being fed into two different, basically Power BI tables. So there's a connection efficiency there. Duplicate also works as well, but I'm going to use reference in this case. And I'm going to go ahead and right click and rename this connection and call this element rooms. So you can see that it's named element rooms, and we have if I go over to the right-hand side, you can see we have some applied steps. Right now, it's just making connection to some source information. But what I want to do is cull this record set down to just the room data. And so what I can do here is I can find my category field and say, you know what, I want to only show the room records here. So you can see that by doing this caret drop down, there are a number of there's basically a list of categories, and this says the list is incomplete because Power BI hasn't loaded everything in. So I'm going to go ahead and hit load more, and you can see that rooms is a category here. I'm going to uncheck that and click on rooms and do that like so. And now we have itemized records of just the rooms. And what you'll also notice as you start to transform your data in this manner, Power BI is applying these transformations as steps. So what this means is that you can always go back in time. The transformations are not permanent. It's kind of basically a set of stored operations that exist on a data set. So you can see that I have a filtered row step where I've filtered out all of the rows just for rooms, and I can obviously adjust the settings there if I want to. You can also do things like, hey, maybe I don't want some of this information in this table here regarding meshes or any of this other stuff. So what I'm going to do is maybe even cull some of this down, and you can even do something like, okay, I'm going to remove these columns. Now I'm not deleting these columns from the data set. I'm actually just adding a step. So that's removing columns from loading into the Power BI environment. So this kind of ability to transform your data sets can be a really useful set of tools to manage things. So I've got now a list of element records for just rooms. Maybe I want to also have the ability to connect my furniture properties or my furniture element records to these rooms. Because, in Revit, if you place like a chair or something, that needs to also get connected into the, that might want to reference a certain room object itself. And within this exported database, element records can be joined to rooms using the Revit IDs of the rooms themselves that are assigned to these elements. So if I go to the element parameter Revit ID tab, or the Revit ID table, you'll see that we have Revit ID, and I can start to apply a very similar set of operations. So I'm going to go ahead and reference this table, and I'm going to go ahead and rename this Revit ID, and I'm going to call this room ID. So I have a little thing that this is only going to be pulling out the room ID from that table. And then through a similar set of applied steps, I can say, okay, I only want to find the room parameter that might exist on different furniture objects. So I'm going to find that. So you can see that I've got a room category of, or name of parameter that I can filter down to. And that's going to, again, cull down this room list, or this parameter list, to just those objects. And then you can see that I have the name of the parameter, and then I also have the value. So this is the room ID in Revit of what these elements belong into or situated within. And so I can even rename this column here as another piece of data transformation. I'm just going to go ahead and rename this. See, where is my rename? Rename. There it is. I'm going to call this the room ID. And again, you can see that all of these are being tracked as applied steps to my object. And then I also might want to remove some of these columns that I know that I'm likely not going to be using in my workflow here. So I'm going to go ahead and remove that column as well. So I've made a couple of connections here. I'm going to go ahead and close and apply this set of steps. And what we're going to see is that Power BI is going to generate now some new data connections in this relationship graph, because we've essentially created now some breakout tables. We're now going to be using these tables in a relational way to build up to the resultant report that Nicole will be going through here. So I'm going to quickly wrap this exercise up so we can get back to the fun stuff, which is the visual. But you'll see that since we've now created these relationships here, Power BI has tried to find where these relationships might belong. And this is kind of where you need to have a bit of a critical eye. A lot of these relationships, sometimes Power BI is really good at finding the relationship or the correct relationship that we want. In other cases, not so much. And so what I typically do at this point is, if I introduce a new data set, is I might even just delete the relationships that Power BI has generated on the fly, and just kind of rebuild them to make sure that I've got the right relationships set out. So what I've done here is I've broken out, we have our element parameter. This is our room IDs for the different elements. And then we have the room objects themselves. So now if I go over here, I can say, all right, I want to join my element, my master or my main element record list. I'm going to join these into my element ID to element ID to the room parameters. So I'm going to have a relationship going there. And after that relationship is completed, I can then do a relationship check that connects the room ID to the Revit ID of our element rooms. So we now have this kind of flow of information that's occurring between the main element record list, the room that these objects belong in, and then the element records here. And what that means is that when I then go into my report view, is I can start to do some stuff when it comes to connecting these data sets together. So for example, I can say, okay, I want to make sure I'm connecting my my element table, which is going to list out the name of every element that I have. I can then say, okay, I want to then find the rooms that they belong to. So I did create a Revit ID for rooms. So we can say, okay, let's have a look at the Revit, the room IDs that these elements might belong to. You can see there's a few elements down here. That's the Revit ID that's being listed. And then finally, I can say, well, let's take a look at the actual Revit room name that these pieces have. So I'm going to grab the name field for my rooms table that I had kind of created and referenced, and now we have those being made available. Let me see if I can zoom this in a little bit, because I know that streams can be sometimes hard to see. And I'll kind of bump up the zoom here. So now we have a relationship that's spanning 3 tables showing the element record, the Revit ID, and then the room. And where this can go, this is kind of the structure that Nicole will be working with, is something that looks like this. You can really build a rather sophisticated network of relationships that will span multiple tables of data and even allow you to connect to other sources of information. This is one where we're connecting the relational database that's produced by Tracer to some external Excel data that's giving us revenue reporting and things like that. So we'll be working with this data structure, and these files will be made available following the demonstration here and when the recording is put up. So hopefully that was some good insight in terms of, like, when you get a Power BI or you get a database and you're working with a database within Power BI, you have a lot of opportunity with Power BI to really format data and explore the connections between different data sets to where it can tell your story in a meaningful way. I'll pass this back over to Nicole.
Awesome. Okay, so here we are back in Power BI in the report view. The template that we used to create this particular report includes all of the connections that Nate was just showing, and I think we'll share this as well after the presentation today, so that you don't have to go through the work of recreating each of those relationships and each of the different tables of pulled out information. So on this report view, we have the same columns and tabs of information that we were showing in the preview, only this time it's for a quarter of the seating bowl. And we'll begin by creating a 2D tracer view. So to do that, you can just click on the 2D tracer visual icon, and it will create a window on the report. You can use these toggles to resize. Sometimes whenever you're resizing up against the filters panel, it'll drag out the filters panel. So you just want to be a little bit cautious if you're doing that when there's a bunch of data loaded into the view, because it could make it take a moment. So we have our 2D panel here. We know that we want to create a plan view of the different rooms, which are actually the sections of the seating bowl. And in order to do that, we'll want to find our element rooms table that we just created earlier. And for 2D view, we'll use location GeoJSON information. You might be familiar with our 3D visual, where we would use a mesh that's been concatenated for the view. But for the 2D view, we want to use location GeoJSON. So if we drop that in the geometry tab, these are all of the different room outlines. The terminology in Power BI is element for each of these that are being displayed. And in order to make this interactive with the other visuals on the canvas, we'll need to also add the same location GeoJSON information to this geometry for highlighting field. So now when we select on a value, it will highlight the appropriate ones. In order to get colors and labels onto this view, we'll have to add more information. And I think it would be helpful for us to have the room number or the section number be that designation on each of these. So in order to do that, we can grab the section number and drop it into category. Power BI will automatically select colors. They might not be super lovely or helpful colors. So we can show you how to change those. And we'll also show the label. So you can jump over to the Format Visual tab, scroll down to Labels, which you can toggle on and off. You can either change the background color or turn off the backgrounds. You have the ability to change the way that the text is viewed. And then this clip by element function would, if the text overlapped the edges of the element, it would clip the element so that it's only visible. I can show that. Clip the elements so that it's only visible within the element versus allowing it to extend beyond the element. So there might be different use cases where both of those are acceptable. There's different fonts, so you can make it either match with the other elements or just make it more clear. We also have the ability to control the way that the elements are being drawn. So we can toggle off and on the edges, change the edge colors, adjust edge thicknesses. If you have point data, you can change the point sizes and the point colors, and even toggle off and on the point edges. And to change the colors, we can jump into data style. Since it's set to categorical, it's referring back to, in the format visual, this category, the information that was dropped here. So each of those different room names or section numbers is displayed here, and you can adjust the colors manually. It does just take a minute to do this, so it's not entirely a huge deal. But another kind of exciting thing for version 3 is that we have the ability to use singular rule. I need to update my visual so that the default color should show up as white in the latest version of the visual. And this singular rule right now is displaying all of these as a single color, which is white or whatever color you would set it to. And in order to use conditional formatting, you would select the function key here. This will pull up the conditional formatting menu, where you can choose different formatting styles for gradient, rule, or field value. And we can input any numerical information or information to be counted into this field and use various summarization methods in order to have the data color specific to those values. So one thing that we could do is color it by room number. We can use the section number as a number value. So you can see that there's duplicate information here. This field is section number as text, and this field is section number as a number. That's important because if you're using section number as text, it's only going to count the section numbers. If you've duplicated it and created it as a whole number, then you'll be able to sum them. That's maybe a little bit of a niche problem, but something that you'll want to be aware of. When you have numerical data, you have a lot more options to be able to sum or average or use any of these other functions. We can choose not to format data, which will go back to the default color of white. We could use a specific color if we want, or we could format empty values as 0. This won't affect our current view because we don't have any rooms that don't have a value associated with them. We can set particular colors for the lowest value and highest value, and we can even add a middle color. We can add custom settings here, so it might be helpful to say anything under 122 is going to be this exact color versus a slightly different shade of that color. And anything over 319 will be this exact color versus a shade of the color. And in different use cases, there might be pros or cons for which numbers you're putting into that. So you can see now that it's recolored each of these by their relationship to the section number. So 2D view created, it's interactive, and there are plenty of other ways that you could color these rooms using any of those other types of data. So now we can go ahead and create a 3D view. The process is pretty similar. We will select the 3D view icon. It'll pop up onto the canvas and you can resize it to whatever size you want. One of the things we should mention is that we have in our templates set the canvas size. So if you select on this background space, you can go to the format page button and adjust the canvas settings. All of our templates are updated to have 1080 by 1920 canvas size, which helps the 3D view have a better appearance. The new version 3 3D view is an improved visual appearance regardless of that, but this really helps it to look very crisp and clean. So now that we're selected on our 3D view, we can start to decide what types of information we want to show in the view. And to do that, we can head back to our element table. Here we have the element meshes concatenated, and we can drag and drop that into the geometry field. Again, we'll want to put that into the highlight field as well. And this is going to pull up all of the different types of geometries that we have in this table. So those big boxes are the rooms that are showing up as 3D meshes. We can filter this by adding a filter to this filters panel, and we can filter by category. So in this case, we really only want to see the floors and the furniture. You can see it's loading up here in the top corner. Another thing that we can do is use context, which we've preset so that everything that is not a seat is context. And we can adjust the visual even more using this context filter so that anything that's flagged as context will have a different appearance than anything that's not flagged as context. If we go into the Format tab, we can look at data style. And for the chairs in particular, I think that having that outline on them can kind of muddy the appearance of the visual. So I will switch that to faces only. Once we add color to those using conditional formatting, it will look a bit different. And then for the context style, it's by default set to ghosted. And that can be toggled off so that these appear to have those thick outlines. So there's quite a bit of variability of what we're able to do using these two different areas of adjustment for the visual. Right now the data is set to categorical, and we can change that again to singular rule. And click on the function button. And in this case, we'll want to use price as the method of setting the color. We can select not to format anything that is not attached to a price multiplier. So in this case, only the seats have a price multiplier associated with them. This way the visual won't format the floors as a color as set by this gradient. We can set a low value as we did before. So let's say anything that's below $50, we can make this a lighter color, and then anything that is a higher value, let's say anything over $200 will be this brighter color. And we can even add a middle color here. That can just default to the middle value. And the visual will reload. And I've done something wrong. This happens, of course, just during webinars.
And I noticed, Nicole, you're using the price multiplier.
Do
you want to use is it the multiplier you want to use, or is there I thought I saw an actual seat price?
Well, the seat price, let's try it. I don't know, actually. I'm following along a set of notes in which I said price multiplier. So let me just check back through this really quickly.
Count likely isn't the one you want to use. You want to make sure you're using summations. So that looks right.
Oh, you know what it is? It's price multiplier. So it's a multiplier, not the seat price.
Sure.
So this
okay, everything is falling.
This is where I've done it. So anything like the highest price multiplier here is at 2.9, and let's just go back to highest value and lowest value. Getting my steps mixed a little bit up. Okay, so what was happening there as this refreshes is those artificial bounds that I was setting were way above the actual price multiplier data, and everything was turning blue because it was under that number. So now you can see that everything is shaded according to its relationship with the price multiplier. And another thing that we could do that might help the visual in being read is to add a tooltip so that when we hover over these seats, rather than just knowing that this area is more expensive and this area is less expensive, is the actual value that's associated with each of those. So we can grab that information and add it to the tooltip. And after this regenerates, we should be able to hover over and see the seat price for each of those. More information that could be helpful to add is the actual row number. And we have that right here. So now when you hover over each seat, you'll be able to see when it regenerates the seat identification information. So the section and row and the seat price. And with that, we've created the first page of our report. It just took a few clicks. We didn't have to do any coding or DAX writing. And this is something that is relatively accessible to most users, again, with those basic understandings of data relationships. So now we can jump over to the second page of our report where we showed that revenue information previously. I'm not going to create these views from scratch because it's a really similar process to what we just showed on the previous page, but we can take a look at each one and how it's constructed and how it's been built to explain what's happening. So in this view, what we're seeing are the seats and their projected probable sales at a 40% vacancy for the stadium. So something that is typical and happens in venues like this is that the seats toward the front tend to sell more often, and seats like the back upper corner tend to sell less often. So in our Excel data set, there are values set for each of those, and the shading that's happening here is referring back to this probability. So there's a 92% chance in this scenario that this seat will sell, versus if we go to the back and hover over, there's a 1% chance. And this is just another way that we can visualize and think about the data. Over in this view, these are being built where the category is set to this projection of revenue for each section versus being set to in the previous page, the room number. So that allows the labels to be those projected values. They're formatted as dollar values, so you have the correct formatting and comma placement. And then we've added the section number to the tooltip as well. Do we want to stop and do some question answer at this point?
Sure. Let's do that. I did want to highlight as maybe a way to close out this report that you've just put together is that we can publish these to the web. And as I indicated before, let me go ahead and get my screen shared here. We have a couple of live examples on the web, and this happened to be one that we published earlier this week. So this is the kind of same kind of report that Nicole just put together. It's been published to the Power BI cloud and is now viewable within the web browser. And when it's inside of your Power BI account, you have options for sharing this report with others, embedding it into a website, creating public links if you want the data to be made available publicly. And both the 2D and the 3D versions of the visual are viewable within desktop browsers like Chrome. And the 3D one in particular requires that WebGL 2.0 be supported by the browser as well. So yeah, we've had we've seen a lot of our customers use this feature quite a bit, especially when it comes to sharing these reports with clients or sharing them internally for model review purposes and things like that. So I think a really good part of this workflow. And I really like that what we're showing here, as you indicated, Nicole, you composed a report on the fly using the basic toolkit of Power BI. You didn't have to get into writing any special formulas. You were able to get going pretty quickly with using the user interface, the no code user interface of this. And the fact that you can go from model to a then web viewable report without having to write code or HTML, we think is rather powerful and profound. So we can get into some of the questions for sure. There were a few that got answered. I typed them in here in the future. I typed them in here, but maybe a few might be worth being pulled forward. There was a question about, is it possible to export more than one Revit model and view them together? And I wanted to bring everyone here to a couple of examples of this. We do have a couple of templates for Power BI that allow you to make connections to several Revit models. So if you download our template, some of that stuff is pre-set up and you can give it a try here. We also have a video tutorial that covers that kind of operation. So if you were to go to our video tutorial section, you would be able to navigate to, let's see where that's under, I think Introduction to Tracer for Revit, and should be listed as one of those tutorials here. I think it's towards the bottom. There it is, combining data for multiple Revit models in Power BI. But we also do have a framework that allows you to centralize data in one location. This is a couple of steps beyond the standard version of Tracer that you download from the website. It's more infrastructure intensive, but we do have what's called Tracer Server that introduces automated data processing, centralized storage of the Revit data, web-based configuration. We also have modules that connect into BIM 360 and those kinds of things. So it's kind of more of an enterprise product that we have here. So I wanted to make sure I brought that forward as well. And that kind of leads to another question that was in the Q&A regarding any options to automate exports from Revit to BIM 360, and that's kind of where our Tracer Server is aimed at supporting there. There were a couple of questions about units of the models that are exported. I thought that's a really good thing to cover. Revit we are basically pulling the underlying text and numeric values that Revit stores. And Revit under the hood at its core, if you were to kind of say, give me this numeric value, maybe it's a length or an area, under the hood, Revit presents that data as imperial units. If you have a model that is set up as a metric file, and you have like meters and millimeters represented as your symbolic units that are being visualized, the underlying Revit data is still in imperial. So we're pulling the underlying imperial units. These are the units that are at the foundation of Revit. But what you can do with Power BI, and Power BI makes it really, really easy to do this, is that you can perform unit conversions within Power BI with very little hassle. It involves finding your numeric properties, for example, say an area property, and you can, with a very simple custom column, multiply it by the proper unit conversion, and then you have your ability to have your units represented in the units that you choose within the environment. We do not do any conversion of units in our post-processing. We made that decision primarily driven by the consistency of our data exports that we're performing. So when you export a model from an imperial model, from a metric model, from a any kind of model, the databases end up with the same kind of baseline of numeric output, meaning that you could do unit conversions wholesale across an imperial portfolio or an imperial and metric portfolio or a metric portfolio, and you're always kind of working with a degree of consistency there. There were a few questions about, let's see. Is there a way to export grids and levels in the project? Yes, those come across as two-dimensional elements, and they also do come across as properties, but they're not necessarily things that are visible in 3D. The three-dimensional objects that you see in 3D are going to be primarily mesh based. And since grids and levels are lines, those typically don't come across in the 3D view. However, they are visible using our 2D visual support. There was a question about Navisworks and Civil 3D. Presently, we are supporting only Revit and then broadly the IFC file format. So the idea being that IFC can capture building information coming from other sources that aren't just Revit. So if you have like ArchiCAD or Vectorworks or Tekla or Bentley products that are exporting IFC, you can get that, but we're not specifically building exporters for Civil 3D and Navis at this stage in our product development. Maybe in the future, I don't want to rule anything out, but right now our demand is primarily driven by Revit and the IFC file format for this particular workflow.
We do have a more advanced dashboard that we can show, and I'll steal the screen back.
Sure.
A little break from
maybe
questions.
this can be like a quick capstone. We are at the hour, so show the one of the kind of more refined products you've got there. Go for it.
So what you're seeing here, hopefully my screen is sharing, is the same information, but rather than having just one discrete page for each of the different scenarios of price and vacancy, we've used some more complex DAX functions and measures to create this responsive dashboard with different sliders. So you can see that if we make adjustments here, the data will begin to react and recolor, and all of the tooltips will update, and we'll even be able to get different sums for each of the sections and various areas of the stadium. So this is perhaps not entirely no code, as we would love to have everything be no code. There is some DAX that needs to happen in order for this to work, but it is potentially a really powerful use case for people who have a lot of different variables in their data sets that want to show everything in a concise way. And something like this would be able to be published on the Power BI website and shared to clients as well.
I think that's a really good point regarding the levels of engagement and skill sets required for Power BI. Power BI is one of those frameworks that it's very easy to initially get into and quickly build reports and with some of the more out of the box no code functionality, but it is also very extensible, meaning that you can get into writing complex formulas, performing calculations across columns, as you indicated, writing DAX scripts and Power Query scripts and things like that to really make some rather sophisticated data management workflows with Power BI. So it's kind of like easy to learn, difficult to master in the long term. But there's a lot there to pick apart and use and continue to learn as you build out your reports for your different use cases. And with that, we're 2 minutes over. I wanted to say thanks to all attendees for showing up, and we hope this was an informative walkthrough. We went through the process of starting with a Revit model, exporting that data to the database schema that we've designed as part of Tracer. We've made connections into Power BI. We did a tour of data transformations in in the kind of the more back end part of Power BI. And then we went through this process of composing reports that are interactive with both 2-dimensional and 3-dimensional data embedded within. So we're very excited about these workflows, and we hope that folks like yourself can get the value out of using business intelligence within a building information modeling context. So thank you very much, and we'll have this session posted up to YouTube likely later today, and also have the data set available for you to download and pick apart. Thank you very much.